Okay, good afternoon to all of you. Our subject is Unix operating system. This subject have marking scheme and semester examination 70 marks, in semester examination 30 marks, internal continuous assessment at 25 marks, practical oral examination 50 marks, total 175 marks. So myself, before going to start a subject, I will introduce myself. Myself, Vinayak Sale, qualification BE Information Technology and MTech Computer Science and Technology. Total experience 14 years. Out of them, a teaching experience is 9.5 years. Industrial experience is 4.5 years. Email ID vmsale@coe.sweri.ac.in. Mobile number 9175799480. Then subject taught during these 10 years is data structure, operating system, discrete mathematical structure, data mining, object oriented modeling and design, then programming languages such as C, C++, Java, .NET, then computer organization, then Unix operating system, then internet and cyber security, computer graphics, design and analysis of algorithm and microprocessor. Then total research publication is 13 papers. Out of them, international journal 1 paper, international conferences 4 papers, national journals 3 papers, national conferences 5 papers. Then we move towards our vision, mission, objective, quality, policies. So institute vision to be recognized among the best institute in India for excellence in technical education. Institute mission to impart value added technical education through ambience of academic excellence, research and life skills by inculcating personal touch and respect in relationship amongst the different stakeholders. Then departmental vision to be nationally recognized for excellence in education, augmented by research in the field of computer science engineering. Department mission to impart value added technical and applied research oriented education by inculcating life skills oriented to industries with emphasis on human values. Then what is a program educational objectives, that is PEOs? The Department of Computer Science and Engineering has its PEOs to produce a graduate who apply the computer science domain specific knowledge and skills in growing software and related industries, demonstrate leadership, professional ethics, project management, and finance related attributes as employees or employers, engaging in lifelong learning for professional advancement to develop innovative solutions for individual or societal problems, demonstrate strong communication skills and ability to function effectively as an individual and a part of team. So PSOs, program specific outcomes. Engineering graduates will be able to understand and design computer system using knowledge of digital techniques, microprocessor, computer organization, advanced computer architecture, operating system, system programming, compiler construction, application softwares, etc. Interpret, analyze, and design software system programming knowledge using algorithmic skills, web technology, big data analytics, networking fundamentals, machine learning, and Internet of Things, adopt applications and emerging fields of computer science and engineering, program outcomes. Engineering graduates will be able to engineering knowledge, problem analysis, design development solutions, conduct investigation of complex problems. So in engineering knowledge, apply the knowledge of mathematics, science, engineering fundamentals, and an engineering specialization to the solution of complex engineering problems. Problem analysis is to identify, formulate, review research literature, and analyze complex engineering problems, reaching sustained conclusions using first principles of mathematics, natural sciences, and engineering sciences. Design or development of solutions. So design solutions for complex engineering problems and design system components or processes that meet a specified needs with appropriate considerations for public health and safety and cultural, societal, and environmental considerations. Conduct investigations of complex problems. Use research based knowledge and research methods, including design of experiments, analysis and interpretation of data, and synthesis of the information to provide valid conclusions. Then, use of modern tools. So, create, select, and apply appropriate technique, resources, and modern engineering and IT tools, including predictions and modeling complex engineering activities with an understanding of limitations. The engineer and society apply reasoning informed by the contextual knowledge to access societal, health, safety, legal, and cultural issues and the consequent responsibilities relevant to the professional engineering practice. Environment and sustainability. Understand the impact of professional engineering solutions in societal and environmental context. Demonstrate demonstrate the knowledge of and need for sustainable development. Ethics. Apply ethical principles and commit to the professional ethics and responsibilities and norms of engineering practice. Then individual and teamwork. Function effectively as an individual and as a member or leader in diverse teams and multidisciplinary settings. Communication. So communicate effectively on complex engineering activities with the engineering community, with the engineering community, with the society at large, such as being able to comprehend and write effective report and design documentation, make effective presentation, and give and receive clear instructions. Project management and finance demonstrate knowledge and understanding of the engineering and management principles and apply these to one's own work as a member and leader in a team to manage projects in multidisciplinary environments. Lifelong learning recognize need for and have the preparation and ability to engage in independent and lifelong learning in the broadest context of technological change. So up to this we have seen a different POs. Then we move towards our syllabus. There are two sections and each section contains four chapters. So first unit is introduction. In this we will study general overview of the system. In that the subparts are history, system structure, user perspective, operating system. There are again two parts, services and about assumption about hardware. Then second part of this chapter contains introduction to kernel. In that there are two parts, architectures of architecture of Unix operating system and introduction to system concept. Then second chapter is buffer cache. There are 5 points. So first part is buffer headers. Second, structure of the buffer pool. Third, scenarios for retrieval of buffer. Fourth, reading and writing disk blocks. And fifth, advantages and disadvantages of cache. Then third, internal representation of files. There are 7 points. First, inodes. Second, structure of regular file. Third, directories. Fourth, convention of path name to inode. Fifth, superblock. Sixth, inode assignment to a new file. Seventh, allocation of disk blocks, other file types. Unit 4, system calls. There are number of system calls such as open, read, write, lseek, close, file creation, change directory and change root, then change owner and change mode, then stat, fstat, dup, mounting and unmounting, link and unlink. Then next chapter, the structure of processes. So there are 4 points, process states and transitions. Second, layout of system memory. Third, the context of process. Fourth, saving context of process. Then chapter 6, process control and scheduling. So here process creation, signal, then process termination, then awaiting process termination, the user ID of a process, system boot and the init process, process scheduling, system call for time, and last point is a clock. Then unit 7, memory management policies. So there are only 3 points: swapping, demand paging, that is demand passing, then a hybrid system with demand paging and swapping, and last chapter is on shell programming. Then in that there are 8 points: shell variables, which contains system variables and local variables, then executing shell script, the read command, positional parameters, the set command, branching control structures such as if, else, that is test commands, then loop control structures such as while, do while, for, that is for do while there is until, then next is expression command. So for the whole syllabus there are three textbooks three textbooks are given in your syllabus. That is, first a textbook is the design of Unix operating system, that is by Maurice J. Batch by PHI publication. These are this book is for a theoretical part, and then for practical part is Introduction to Unix and Shell Programming by M.G. Venkatesh Murthy by Pearson Publication, and third book for programming Unix concepts and applications by Sumitabh Das. Then reference books Unix concepts and administration by Sumitabh Das, third edition by Tata McGraw Hill publication, and second reference book is Unix Shell Programming by Yashwant Kadnetkar, BPB Publications. So your whole syllabus is covered on first textbook, that is the your whole syllabus your whole syllabus is covered in first textbook, that is the design of Unix operating system by Maurice J. Batch. So what about the title of the subject? The title of subject is Unix operating system. We will study the term Unix, then operating, and the system. We will see the actual meaning of each term. So Unix is uniplexed information computing system or universal network information exchange. Operating, that is involve a kind of operation in action or full operation like active, alive, functioning, going, operative, running, working. Then meaning of system is a group of interacting, interrelated. System means a group of interacting, interrelated, or interdependent element forming a complex whole. So the Unix was earlier known as Unix, UNICS, which stands for Uniplex Information Computing System. Operating, that is a directing, managing, executing, manipulating, management, conducting, administrating, ordering, regulating, supervising, and running. System, a set of principles or procedures according to which something is done, an organized scheme or method. So, what is the central idea of the subject? Unix is an operating system developed in Bell Laboratories of AT&T and is an example of multitasking and multi-user operating system. It provides its users with program development tools, electronic communication facilities such as electronic mail, text editors, and text formatters. Unix is the most powerful multi-user multitasking operating system. The basic concepts of Unix were originated in the Multics project in 1969. The Multics system was intended as a time-sharing system that would allow multiple users to simultaneously access mainframe computers. What is the importance of subject in your syllabus? Unix is an operating system. It supports multitasking, multi-user functionality. Unix is most widely used in all forms of computing system such as a desktop, laptop, and servers. On Unix, there is a graphical user interface similar to Windows that supports easy navigation and support environment. Unix is powerful and very popular operating system which is widely used both workstations and servers. Unix was designed to be more portable, multi-user and multitasking in a time-sharing configuration. Unix system Unix system are classified in various concepts such as first part of this is plain text for storing data. Then what are course prerequisite and what are the outcomes of this course? The course prerequisite for this subject requisite is prerequisite knowledge of operating system concepts and C programming language is needed. And the outcomes of this course. At the end of this course, student will be able to describe architecture of Unix, its kernel and file system, apply algorithm of regular file for inode assignment and disk block allocation. Then student will be able to use system calls and program shells. Student will be able to describe structure of process, memory and input output management, and a student will be able to implement program using shell script. Then 5.5 plus 2 point formula. So there is a continuous assessment for a 25 marks term work. So 5 marks and 2 marks. So 5 marks or 5 points. This 5 point contains such as for ISE and chapter test 10 marks, for assignment and getting checked in time 5 marks, for journal or oral 5 marks, for a triple B and getting checked in time 3 marks, and prelim test 2 marks. These are 5 points and 2 points. The following 2 points will have overall effect on the marks obtained by the students through above 5 points. First point is attendance and second is a general behavior and participation. So we move. This is up to this we have seen the vision, mission of institute and department, then POs, PSOs, then detail the syllabus, central idea of the subject, then importance of the subject. Now we move towards introduction, that is a unit first. A name of unit first is introduction. In this chapter we will study a general overview of the system. In that we will study in this chapter we will study a general overview of the system. In that there are 5 points: history, system structure, user perspective, operating system services, assumption about hardware, and second point is introduction to kernel. There are 2 points: architecture of Unix operating system, then introduction to system concepts, and the whole syllabus of this chapter is covered in the book The Design of Unix Operating System by Maurice J. Batch by PHI publication. These are the assignment questions. Take a screenshot or write down. First question is, what are the hardware assumptions needed to run Unix operating system? Second, explain architecture of Unix operating system with the help of block diagram. Third, explain the architecture of kernel. Explain the following terms of hardware assumptions for Unix operations or Unix operating system. First is kernel model. second user mode, third interrupts, fourth exceptions, fifth execution levels. About the title of the chapter, the title of chapter is Introduction, which gives the overview of Unix operating system 5. The Unix system has become quite popular since its inception in 1969, running on machines of varying processing power from microprocessors to mainframes and providing common execution environment across them. The system is divided two parts. First part consists of programs and services that have made the Unix system environment so popular, and it is the part readily apparent to users, including such programs as the shell, mail, text processing packages, and source code control systems. The second part consists of the operating system that support these programs and services. So this chapter gives a detailed description of the operating system. It concentrate the description of Unix System 5 produced by AT&T, but considers interesting features provided other versions also. It examines the major data structures and algorithms used in the operating system that ultimately provide users with standard user interface. What is the central idea of the chapter? This chapter covers a general overview of the systems such as history, structure, user perspective, operating system services, assumptions, and hardware, etc. Also, it covers introduction to kernel containing architecture of Unix operating system, introduction to system concepts, kernel data structure, system administration. So this chapter provides as introduction to Unix system. It review its history and outlines the overall system structure. What is importance of this chapter in your syllabus? Before studying any operating system, it is required to consider overview of it. So this chapter plays important role whole syllabus of this subject. So what will be the outcome? It after studying this chapter, you will be able to describe architecture of Unix, its kernel and file system. So we are going to start of this chapter. So first point is a general overview of the system. In this we will study history, In that, there are again four parts: system structure, user perspective, operating system services, and assumption about hardware. So, what is the history regarding the Unix operating system? So, in 1965, Bell Telephone Laboratories joined an effort with the General Electric Company and Project Mac of the Massachusetts Institute of Technology, that is MIT, to develop a new operating system called as Multics. The goal of Multics system were to provide simultaneous computer access to a large community of users, to supply ample computation power and data storage, and to allow users to share their data easily if desired. Many people who later took part in the early development of Unix system participated in the Multics work at Bell Laboratories. Although a primitive version of Multics system was running on GE 645 computer by 1969, it did not provide the general service computing for which it was intended, nor was it clear when its development goal would be met. Consequently, Bell Laboratories ended its participation in the project. So, in an attempt to improve their programming environment, Ken Thom- Thompson, Dennis Rich, and others sketched a paper design of file system that later evolved into an early version of the Unix file system. Thompson wrote papers that stimulated the behavior of proposed file system and of programs in a demand paging environment, and he even encoded a simple kernel for the GE 645 computer. At the same time, he wrote a game program, Space Travel, in Fortran for a GCOS system, but the program was unsatisfactory because it was difficult to control spaceship and the program was expensive to run. Thomson later found a little used PD. Thomson later found a little used PDP-7 computer that provided good graphic display and cheap executing power. Programming space travel for the PDP-7 enabled Thomson to learn about machine, but its environment for program development required cross assembly of the program on GCOS machine and carrying paper tape for input to the to create a better development environment. Thomson and Reach implemented their system design on the PDP-7, including an early version of the Unix file system, the process subsystem, and a small set of utility programs. Eventually, a new system no longer needed the GECOS system as a development environment but could support itself. The new system was given the name Unix upon on the name Multics coined by another member of the Computing Science Research Center, Brian Kerrigan. So there are several reasons have been suggested the popularity of Unix operating system and its a success. So first reason is system is written in high level language, making it easy to read, understand, change and move to other machines. So Reach estimates that the first C program was 20 to 40% larger and slower because it was not written in assembly language. But the advantages of using higher level languages for outweigh and the disadvantages. It has a simple user interface that has a power to provide the service that user want. It provides primitive that permit complex program to be built from simpler programs. It uses hierarchical file system that allows easy maintenance and efficient implementation. It uses a consistent format for files, the byte stream, making application program easier to write. It provides a simple, consistent interface to peripheral devices. It is multi-user, multi-process system. Each user can execute several processes simultaneously. It hides the machine architecture from the user, making it easier to write programs that run on different hardware implementations. There are total 8 points for popularity and success of Unix operating system.
हॅलो सर.
Huh?
टाइम झालाय सर.
Okay. This is the architecture of Unix operating system. Okay. We'll study tomorrow's lecture. Before that, you see the architecture.